What if I told you that in the highest echelons of academic research, half the value of a multi-year, million-dollar study doesn't actually come from the groundbreaking data itself?
Right, which sounds completely counterintuitive, especially in a world where, we're conditioned to just hide all our flaws.
Exactly. I mean, it actually comes from a single chapter at the very end of the paper where the researcher is practically forced to admit everything they did wrong.
Yeah, but in the architecture of research, that vulnerability, it's actually the ultimate proof of rigor.
Welcome to this deep dive. Today, we are taking you right into the engine room of research methodology.
The real nuts and bolts of it.
Yeah, the mission today is to demystify the most pivotal transformation in any study. We're looking at how you take a chaotic, overwhelming pile of raw data and actually forge it into meaningful, reliable human knowledge.
Because data in its raw form is, well, it's completely silent.
Right? It doesn't speak for itself. We're getting into the mechanics of data analysis, the philosophical battleground between quantitative numbers and qualitative stories, and those strict, almost ruthless rules for writing a powerful discussion chapter.
We're basically looking at the entire life cycle of meaning. A spreadsheet with 10,000 rows of survey responses is just digital noise until you apply a specific philosophical lens to it.
Okay, let's unpack this, because before we can write a single word about what our findings actually mean, we have to figure out what the data is saying.
And it requires choosing a lens.
Right. And the modern research landscape divides this into two incredibly distinct camps, quantitative and qualitative. Let's start with the numbers.
Good place to start. So the quantitative approach is entirely rooted in a philosophy called positivism.
Positivism.
Yeah.
Yeah.
Positivism views the world as a place governed by objective, measurable truths. It operates on deduction.
Meaning you start big and narrow it down.
Exactly. You start with a massive, abstract concept, let's say organizational culture, and you meticulously chisel it down into numerical metrics before you ever collect a single piece of data.
Right, you have to operationalize it. I mean, if I'm a positivist, I can't just walk into a company and say, wow, the vibe here is terrible.
No, absolutely not.
I have to build a 50-point Likert scale survey measuring, employee turnover intent, frequency of cross-departmental emails, self-reported burnout levels. I have to translate the vibe into a spreadsheet.
And what's fascinating here is that the measurement is treated as a completely separate event from the analysis.
How so?
Well, you build the ruler, you measure the room, and only then do you look at the numbers. And once you have those numbers, you face the first real hurdle, which is cleaning the data.
Oh, man, which is never as glamorous as people think.
It's tedious.
Yeah, it's not just hitting run on a statistical model and kicking back.
Not at all. Data cleaning is ruthless. You are looking for outliers that could skew everything.
Give me an example of an outlier that would ruin things.
Okay, so if you are measuring reaction times, say in a psych study, and one participant took 45 minutes to press a button because they fell asleep, that single data point will completely destroy a standard mean.
Oh, wow. Yeah, that would throw the whole average off.
Completely.
Yeah.
So you have to make complex decisions about missing data imputation too. Like, do you drop a participant who skipped one question? Or do you substitute the mean of their other answers to fill in the blank?
Because if you apply sophisticated statistical models to dirty data, you just get highly precise garbage.
Exactly.
Okay.
Garbage in, garbage out.
So assuming the data is clean, we move into the actual statistical testing. And I really want to get into the mechanics of this rather than just listing the tests.
Yeah, let's look under the hood.
Because I think people use terms like correlation or significance all the time without understanding the actual engine. Let's look at bivariate analysis, which is comparing two variables.
Right, just two things.
If my data is parametric, meaning it's normally distributed, fitting that nice, predictable bell curve we all know, how does something like a Pearson correlation coefficient actually work?
It's an elegant mathematical mechanism, really. The Pearson correlation isn't just looking to see if two lines on a graph generally go up at the same time.
It's deeper than that.
Much deeper. It mathematically calculates the covariance of your two variables, which is how much they change together, and then divides that by the product of their standard deviations.
Meaning it's standardizing the relationship.
Precisely. It gives you an absolute value between -1 and +1.
Okay, so what does a positive one actually look like in the real world?
If it's a perfect positive one, every single time variable A goes up a unit, variable B goes up a totally predictable amount. It creates a perfect tight line on a scatter plot.
But it also gives you a p-value, right? Which is
Mm.
arguably the most misunderstood metric in all of research.
Oh, well, without a doubt.
It's the famous p is less than 0.05. Everyone treats that like it's the holy grail of proving your theory is right.
Which is a massive misinterpretation. A p-value of less than 0.05 does not mean your theory is right.
Wait, really? Because I feel like that's how it's reported in the news all the time.
All the time, but it's wrong. It simply means that if the null hypothesis were true, meaning if there were actually no relationship between these variables in the real world, the probability of you seeing the exact data you just collected is less than 5%.
So it's a measure of surprise.
Yes. It means your data is highly surprising if nothing is actually going on.
That is a subtle but massive distinction. Okay, so Pearson is for two variables. What if I'm looking at 3 or 4 groups?
Like a multi-group study.
Right. Say I'm testing a new blood pressure medication across 3 different dosage groups plus a placebo group. I can't just run a dozen different Pearson correlations, right?
I mean, you could, but you would be heavily inflating your risk of a false positive, what statisticians call a type I error.
Because every time you roll the dice, you might just get lucky.
Exactly. Every time you run a test, there's a small chance of finding a fluke. If you run 10 tests, those flukes compound. That is where an ANOVA, an analysis of variance, comes in.
So how does an ANOVA solve that compounding error problem? Like, what is the actual mechanism doing?
An ANOVA fundamentally looks at the signal-to-noise ratio. It compares 2 different types of variance.
Okay, break that down for me.
First, it calculates the variance between the groups. Are the averages of the high-dose group, the low-dose group, and the placebo group very different from each other? That's your signal.
Okay, that makes sense. And the second type?
Then it calculates the variance within the groups. Are the people inside the high-dose group all clustered tightly around the exact same blood pressure, or are they wildly all over the place? That's your noise.
So if the groups have wildly different averages, but everyone inside the individual groups is behaving exactly the same, you have a massive signal and very low noise.
You've just described a high F statistic.
Oh, nice.
Yeah, the ANOVA takes that between-group variance and divides it by the within-group variance. If the resulting number is large enough, the ANOVA tells you, yes, at least one of these groups is statistically significantly different from the others.
But it doesn't tell you which one is different.
It does not. It just gives you the green light to go looking further with post-hoc tests.
Now, all of that relies on the data playing nice. It relies on the assumption of parametric normal distribution, the bell curve.
Right.
But the real world is often incredibly lopsided. Say I'm measuring household income in a major city. That is never a bell curve.
Never.
You have a massive cluster of people making between $40,000 and $80,000, and then a tiny, incredibly long tail of multimillionaires that just completely breaks the mathematical assumptions of an ANOVA.
And that is exactly when you must cross over into non-parametric tests. If you use an ANOVA on highly skewed income data, your results are invalid because the mean itself is no longer a reliable anchor point.
Because one billionaire ruins the average for everyone in the neighborhood.
Correct.
So what is the alternative engine? The field points heavily toward things like the chi-square test for categorical non-parametric data. Let's map how that works.
The chi-square test is brilliant in its simplicity, honestly. It operates entirely on the concept of observed frequencies versus expected frequencies.
Okay, give me a scenario.
Imagine you're investigating whether a company's promotion rates are biased by gender. You have a contingency table, basically a grid. Male and female on one axis, promoted and not promoted on the other.
So categorical data. You aren't measuring a continuum. You are just counting heads and buckets.
Yes, just counting frequencies. The chi-square test first asks a hypothetical question.
Which is?
If gender had absolutely zero association with promotions in this company, based on the overall promotion rate, how many men and women would we logically expect to see in each bucket?
So it calculates a perfectly fair, mathematically expected grid.
Exactly. And then it compares a hypothetical fair grid to reality.
The actual heads and buckets.
Right. It takes your observed data, subtracts the expected data, squares the result to get rid of negative numbers, and divides it by the expected data.
Okay, so finding the difference.
Yeah, and it aggregates those differences across all the buckets. If your observed reality is drastically different from the mathematically expected fairness, your chi-square value spikes.
And that tells you what?
It tells you, hey, there is a statistically significant association here that is not due to random chance.
That perfectly encapsulates the positivist mindset. We take complex social dynamics like workplace bias, operationalize them into contingency tables, and run mathematical models to find objective truths.
It's very clean.
It is, but there is a massive limitation here. The tri-square test can tell us that women are being promoted less, but it cannot even begin to tell us why.
Which is the fundamental vulnerability of quantitative research. It strips away all context in the pursuit of numerical precision.
Right.
And that realization forces us into the entirely separate philosophical universe of qualitative research.
Right. And if quantitative is driven by positivism, qualitative is driven by interpretivism, and we cannot gloss over what a radical philosophical shift this is. Interpretivism basically looks at the positivist and says, your objective reality is an illusion.
That's pretty much it. Interpretivism operates on the core assumption that reality is complex, it is incredibly local, it is multi-layered, and it is intensely subjective.
So they don't even believe in facts.
The very idea of an absolute fact in the social sciences is viewed with deep suspicion.
So how do you study a world where you don't believe facts exist? That sounds impossible.
You study meaning.
Yeah.
The goal is no longer measurement. The goal is a concept called Verstehen, which is a term popularized by the sociologist Max Weber.
Verstehen, what does that translate to?
It roughly translates to an empathetic, deep understanding of human social activities and lived experiences. You aren't trying to prove that something happened with a p-value. You are trying to understand how the people who experienced it constructed their own reality.
Let's ground this. If positivism is setting up a camera at an intersection to count exactly how many cars run a yellow light, what is interpretivism?
Interpretivism is ignoring the camera entirely, tracking down the actual drivers, and conducting an hour-long interview with them about what was going through their mind at that exact second.
Oh, I see.
Yeah, so one driver ran it because they were rushing a sick child to the hospital and felt a moral imperative that overrode the law. Another ran it because they were texting, totally unaware of their surroundings.
But the camera, the positivist lens, just records two identical data points,
Yeah.
one infraction, one infraction.
Exactly. Well, the interpretivist lens reveals two entirely different human phenomena.
And to analyze this phenomena, you aren't using an ANOVA. You are using methods like narrative analysis. And I want to dive deep into exactly how a researcher executes this.
It's a very involved process.
Because I think people assume qualitative analysis is just a researcher sitting in an armchair, reading a transcript, and writing an essay about their feelings.
That is a massive misconception. Rigorous qualitative analysis is incredibly systematic.
Take narrative analysis, for instance. Let's look at the example of analyzing a convicted prisoner's justification for their crime. You have 100 pages of interview transcripts. How do you actually code that?
Well, you aren't just looking for the facts of the crime. You are analyzing the structural architecture of their narrative. A qualitative researcher might code specifically for linguistic distancing and agency.
Linguistic distancing, meaning what?
Meaning, when the prisoner describes the lead-up to the crime, do they use active voice, like, I bought the weapon, I walked to the house?
Versus passive voice.
Right, do they suddenly shift to passive voice and externalize agency when the actual crime occurs? Like, the gun went off, the situation got out of control.
Oh, that is fascinating. You are mapping how they grammatically absolve themselves of responsibility.
You systematically code the entire transcript for those exact linguistic shifts.
Yeah.
You categorize when they cast themselves as a victim of circumstance versus when they claim agency.
So you're building a framework.
You are building a theoretical model of how individuals construct a narrative to protect their own psychological identity after committing an act that violates societal norms.
Okay, let's unpack this. If qualitative data operates on the core philosophical belief that reality is intensely subjective, and we are just interpreting their interpretations, how do we establish any sort of scientific reliability?
That's the million-dollar question.
How does this not just dissolve into complete subjectivity, where every researcher reads the transcript differently based on their own biases?
This brings up the critical concept of qualitative rigor, which relies heavily on transparency and audit trails. In quantitative work, reliability means if I run the statistical model again, I get the exact same number.
Right.
But in qualitative work, reliability comes from inter-rater reliability and highly transparent categorization.
So you have multiple people code the exact same transcript.
Exactly. I give you the prisoner's transcript,
Yeah.
and I give 3 other researchers the same transcript, along with my codebook defining exactly what constitutes linguistic distancing.
And then you compare notes.
If all 4 of us independently highlight the exact same sentences, we have established robust inter-rater reliability. It's no longer just my subjective feeling. It is a demonstrable, systematically verifiable pattern in the text.
So we have these two vastly different engines of knowledge. The quantitative mechanics giving us the scale, the variance, the what, and the qualitative coding giving us the context, the agency, the why.
Right.
It seems painfully obvious that if you really want to understand a complex problem, you would be foolish not to use both.
And that leads us perfectly to the pragmatic middle ground, which is mixed methods research.
Because sometimes a statistical anomaly without a human story is just a baffling mystery, and a profound human story without statistics is just an isolated anecdote.
That is the core tenet of the philosophy of pragmatism. Pragmatism dismisses the whole turf war between positivism and interpretivism.
They just don't care about the fight.
Exactly. The pragmatist argues that the research question itself should dictate the methods, not some dogmatic adherence to a single philosophy. It introduces the concept of abductive reasoning.
Now, we've talked about deduction, starting with a theory and testing it mathematically. And we've talked about induction, starting with messy observations and building a theory. What is abductive reasoning?
Abductive reasoning is often described as the inference to the best explanation. It allows the researcher to pivot fluidly between induction and deduction based on what the data is demanding at that moment.
So it's more flexible.
Much more. You encounter a surprising fact, you construct the most plausible hypothesis to explain it, and then you test that hypothesis. It's highly iterative.
And the most powerful tool in the pragmatist's arsenal is triangulation. Let's dissect this, because there are specific ways to triangulate.
Yes, there are.
Let's say we are investigating a massive, catastrophic structural failure, like a bridge collapses, or a tech company's entire server grid goes down for a week.
If you rely on a single method there, you are incredibly vulnerable to blind spots. Data triangulation means gathering multiple, distinct types of data.
So in the server crash scenario, what does that look like?
You don't just look at the system error logs. You pull the error logs, sure, but you also pull the Slack transcripts between the engineering team during the outage, and you look at the historical maintenance schedules.
Because if the error logs say it was a memory overload, but the Slack transcripts reveal that a senior manager demanded an untested update be pushed live despite warnings, the logs alone give you an incomplete, arguably false narrative.
Exactly. The human element changes the data entirely. And then you layer in methodological triangulation.
Which is what?
Well, you don't just stick to analyzing digital text. You conduct a wide-scale anonymous quantitative survey of the engineering department about psychological safety, and you pair that with in-depth, one-on-one qualitative interviews with the key developers.
This requires specific architectural designs, though. You don't just collect a bunch of different data streams and throw them into a document.
No, it would be chaos.
The field outlines very deliberate ways to sequence this. Let's look at the explanatory sequential design.
In explanatory sequential, the temporal order is fixed. It's quantitative first, qualitative second.
Numbers, then stories.
Right. You deploy your broad numerical instrument, you run your ANOVAs or chi-score tests, and you generate a set of findings. But invariably, quantitative data raises profound questions it just cannot answer.
So you design a qualitative phase specifically to explain those statistical anomalies. Give me a concrete scenario for this.
Imagine you administer a massive survey measuring employee engagement across a multinational corporation.
Okay.
You run the data, and you find a highly significant statistical anomaly. Let's say engagement scores in the European division have plummeted by 40% in the last 6 months, while the rest of the world remained completely stable.
Okay, so you found the fire.
The quantitative data provides the exact parameters of the crisis, but a blank survey response or a low Likert score cannot tell you why they are disengaged.
So phase 2 is launching qualitative focus groups, specifically targeting the European division to ask what changed.
Precisely. You use the qualitative data to elaborate on the exact parameters defined by the quantitative data.
The inverse of that is the exploratory sequential design, right?
Right.
Qualitative first, quantitative second.
Yes. You use this when a phenomenon is so new or so poorly understood that you literally do not know what variables to measure yet.
You can't write a survey because you don't even know the right questions to ask.
Like studying the very early days of a completely new subculture or a novel technological disruption.
So you have to start with the stories.
Exactly. You start inductively. You conduct unstructured interviews, you look for emerging themes, and you build a grounded theory. Then, you use those qualitative insights to construct a quantitative instrument, like a new psychometric scale, and you deploy it to a massive population.
just to see if your highly local qualitative findings generalize across a broader demographic.
Exactly.
And then there's convergent design, where you run both simultaneously.
Here's where it gets really interesting. If we think about how complex systems actually operate, you often can't wait to do things sequentially. Think of a complex urban traffic study trying to reduce congestion.
Okay, previously I've heard this described as using a satellite to view a forest while using a magnifying glass to view the soil, but I think that analogy falls apart a bit because a satellite can't focus on the dirt. The traffic study works much better.
I agree, the traffic study is a better analogy. In a convergent design for a traffic study, you have digital sensors at every intersection, counting the exact volume and speed of cars 24 hours a day.
That is your continuous quantitative stream.
At the exact same time, you have researchers at key transit hubs, interviewing commuters, gathering daily travel diaries, and understanding the behavioral choices, like why someone chose the bus today instead of driving.
You are gathering the structural data and the behavioral data concurrently, and the goal is to merge them in the analysis phase to create a holistic, three-dimensional model of the city's transit ecosystem.
You merge the data sets to validate each other in real time. If the sensors show a massive slowdown on Main Street, but the commuter diaries reveal people are deliberately taking that route because a new popular coffee shop opened, you have converged the what with the why.
Okay, so we've journeyed through the quantitative mechanisms, the qualitative coding, and the pragmatic architecture of mixed methods. You have successfully gathered, cleaned, analyzed, and triangulated your data. You now have a colossal pile of findings.
And this is where many researchers, especially novices, make a fatal error. They believe that their findings are synonymous with knowledge.
But they are not.
They are not.
Which brings us to the crucible of the entire research endeavor, the discussion chapter. This is arguably the most intimidating part of a study, because if you just hand a reader a list of p-values and thematic codes, their response is going to be, so what?
Exactly. The discussion chapter is where data undergoes the alchemy into knowledge.
Yeah.
It is the designated space in academic architecture where you interpret the significance of your findings in light of what is already known, and where you explicitly state your new contribution to the field.
But let's act as a warning beacon here. What is the absolute most common trap researchers fall into when they sit down to write this chapter?
The primary trap is treating the discussion chapter as a summary. Researchers will simply list their results again, maybe using slightly different adjectives, like, as shown in Chapter 4, variable X correlated with variable Y.
Just regurgitating the data.
Right. If you are merely describing what the data is, you are not discussing it. The reader already read the results chapter. You must pivot from description to interpretation. Explain the underlying causal mechanisms that might have driven that specific result.
And there is a structural rule here that I find fascinating regarding introducing new data.
Well, it is a cardinal sin of academic writing.
So if I'm deep into writing my interpretation of the European division's plummeting engagement scores, and I suddenly remember this one incredibly poignant quote from a focus group that perfectly illustrates my point, but I forgot to include it in the results chapter, I can't just slide it into the discussion.
No, absolutely not. Doing so fundamentally compromises the structural integrity of your argument.
Why is it such a big deal?
Think of it like a legal trial. The results chapter is the discovery phase and the presentation of evidence. The discussion chapter is the closing argument. A lawyer cannot introduce a surprise piece of evidence during their closing argument that the jury has never seen before. It completely violates the rules of the court.
So if the quote is that critical, I have to go all the way back, revise the results chapter to formally introduce it, and only then can I discuss.
No, it requires meticulous scaffolding. You begin by re-anchoring the reader. Briefly restate the core research problem and the primary objectives. Give a highly condensed overview of the major findings, just enough to orient them before you dive into the deep end of interpretation.
And the field is incredibly strict about the tone and language used here. It demands clarity, no jargon.
Excessive jargon in a discussion chapter usually masks a lack of profound understanding.
Interesting. So if you're hiding behind big words...
You don't get it yourself. If you cannot explain the significance of your complex statistical model in plain, precise language, you haven't fully grasped its implications yourself.
I want to highlight a highly specific grammatical rule that operates as a kind of secret code in these chapters, the use of verb tenses.
It is subtle, but it completely dictates the authority of the text. When you are discussing your own interpretations and the new knowledge you have generated, you use the present tense.
Like the data suggests, or this finding indicates.
Exactly. You are establishing a current, living truth.
But when you are contextualizing this against the rest of the scientific community,
You shift to the past tense, Smith argued, or Jones found, because their research is historical precedent. By managing your tenses, you are grammatically separating the foundation of the past from the novel contribution you are making in the present.
that is a masterclass in structural writing. Okay, so you are using the present tense to interpret your findings, but your findings don't exist in a vacuum. You have to weave them into the existing web of human knowledge.
This is the contextualization mandate. You must compare and contrast your findings with the existing literature.
But crucially, you do not isolate this in a separate section called comparison with literature.
No, it shouldn't read like a book report appended to the end of the chapter.
Right.
It must be interwoven into the interpretation itself. As you explain why the European engagement scores plummeted, you immediately anchor it against previous studies on cross-cultural management during economic downturns. You are actively demonstrating how your specific piece of the puzzle fits into the broader picture.
And this is where things get truly exciting, because inevitably your puzzle piece doesn't quite fit. You run into unexpected findings.
The anomalies.
I have to imagine there is a massive psychological temptation for a researcher who has spent 3 years developing a beautiful, elegant theory to just quietly ignore a data point that contradicts everything.
The temptation is immense, believe me. But burying an anomaly is academic malpractice. You must highlight unexpected findings with absolute transparency.
You just put it all out there.
You present them clearly, and then you speculate, based on logic and existing theory, why they might have occurred.
Because the anomaly isn't a failure, it's a signal.
Historically, unexpected findings have driven some of the greatest paradigm shifts in science. When a highly robust statistical model produces a result that defies all existing literature, that is the universe telling you that the existing literature is incomplete.
It's pointing the way forward.
The anomaly maps the frontier for the next generation of researchers.
So we have interpreted the data, we have woven it into the historical context, and we have fearlessly highlighted the anomalies. Now, we have to answer the ultimate question that every single reader, peer reviewer, and funder is asking.
So what?
So what does this all mean? We have to explicitly outline the implications of the study. And the architecture demands we categorize these implications into 3 distinct buckets. Let's break them down.
The first bucket is theoretical implications. This addresses the academic ecosystem. How do your findings alter the theoretical landscape?
Like, did you extend an existing theory to a new demographic?
Right. Did your anomaly challenge a core assumption? Or did your mixed methods approach synthesize 2 previously siloed concepts into a brand new framework?
You are explicitly stating how you have upgraded the software of human knowledge.
Precisely. Now, the second bucket is practical implications.
This is where the rubber meets the road.
This is about actionable utility. If you are a business leader, a policymaker, or a clinical practitioner, how does this study change your operations on Monday morning?
Right, what do they actually do with this?
If your research on supply chain resilience during geopolitical crises yielded specific findings, your practical implications must tell the logistics manager exactly what contingency plans they need to restructure.
You can't just leave it abstract, you have to translate it into operational strategy. And the third bucket.
Methodological implications. This is a service to your fellow researchers. Did your exploratory sequential design pioneer a highly effective new way to measure a difficult variable?
Or did your specific combination of data and methodological triangulation overcome a common bias?
Exactly. You are sharing the blueprints of the new tools you built so others can use them.
Okay, so picture this. You have just spent 20 pages proving your theoretical brilliance. You have provided actionable strategies for Fortune 500 CEOs. You have offered new tools to your academic peers. You have built a fortress of knowledge.
And then
And then the structural rules of research force you to pick up a sledgehammer and start looking for cracks in your own walls.
yes, you must write the limitations section.
This is the part that fascinates me the most. We started the show talking about this. You are actively required to point out the flaws, constraints, and weaknesses of your own work. Why on earth would you hand your critics a loaded gun?
It seems crazy, right?
If I spend an entire paragraph explaining that my survey response rate was lower than optimal, or that my qualitative interviews were geographically restricted to just one city, won't a reviewer just throw the whole paper out?
It is a fundamental paradox to the layperson, but it is the bedrock of scientific credibility. Hiding your limitations destroys trust. Acknowledging them proactively builds it.
So it's about intellectual honesty.
Writing a robust limitation section is the ultimate demonstration of intellectual honesty and rigorous self-awareness.
You are preemptively showing the jury that you know exactly where the evidence is thin.
But more importantly, you are preventing the dangerous overgeneralization of your findings. You are drawing a precise boundary line around your knowledge.
Bounding the truth.
You are saying, inside this specific perimeter, within this industry, with this sample size, using these exact measurements, my findings are highly robust. But do not recklessly apply these findings outside this perimeter.
Like, my data on tech sector burnout is valid, but do not assume it applies to emergency room nurses.
Exactly. You are managing the boundaries of truth. But there's a critical tactical maneuver here. When you state a limitation, you must immediately contextualize it.
Meaning you can't just say, well, the data is bad, sorry.
Right. You must explain why that specific limitation does not invalidate the core findings of your study.
You say, while the sample size was constrained to the tech sector, the profound statistical significance of the variance suggests the underlying psychological mechanism is robust enough to warrant further investigation.
Exactly. You acknowledge the flaw, and you structurally contain it, which leads perfectly into the final requirement of the chapter, future research directions.
Passing the baton.
Your limitations essentially write your future research section for you. If your limitation was a geographically restricted sample, your future research directive is for someone to replicate the study in a cross-cultural context.
Oh, that makes so much sense.
If your limitation was the reliance on a cross-sectional survey, which is just a single snapshot in time, you call for a longitudinal study to track the phenomenon over a decade.
And then the conclusion. The final summation of the key discussion points, reinforcing the study's ultimate contribution. And as we noted earlier, you shift back to the past tense because the active work of this specific study is now complete. It belongs to history.
It is the final brick you mortar into place before you step back from the wall.
We have covered incredible dense ground today. We started with the rigid positivist mechanics of quantitative math, deconstructing the signal-to-noise ratio of ANOVAs and the observed versus expected logic of chi-square tests.
We covered a lot of math.
We really did. And then we crossed over into the deeply subjective, interpretivist universe of qualitative stories, mapping the rigorous coding of human agency.
And we looked at the abductive brilliance of blending them, both through mixed methods and triangulation.
And finally, we walked through the strict, honest, almost architectural rules of the discussion chapter. The crucible where silent data is finally translated into applied human knowledge.
It is a grueling, immensely demanding intellectual process, but it is the only reliable engine we have for moving forward in the dark.
Before we wrap up this deep dive, you have a final thought for the listener, a way to reframe everything we've talked about today.
Yeah, if we connect all of this to the bigger picture, think about that mandatory requirement we just discussed. Every single piece of rigorous academic research, no matter how profoundly groundbreaking, no matter how many millions of dollars funded it, is structurally required to end with a section titled Limitations in Future Research.
Right.
It begs a fascinating philosophical question for you to consider. Is our collective human knowledge ever truly finished and settled? Or is the entire pursuit of truth just the act of adding single imperfect bricks to a wall that will never, ever actually be completed?
It is a deeply humbling thought. You know, when we look for answers, we want the certainty of a clean binary outcome. We want the data to just tell us yes or no.
But it rarely does.
Right. But what the rigorous architecture of research tells us is that reality isn't a static, solvable equation. It is an ongoing, endlessly complex conversation. And the ultimate goal of a great study isn't to provide the final perfect answer, it's to ensure that the next question we ask is infinitely better than the last. Thanks for diving deep with us today.